Sarah, that's a no? Oh, okay. Well, try to wake you up. All right, what do you guys think? The log base 2 of 8. Now remember, when you're doing, this is just review because I thought a lot of you, I felt like few of you were a little confused yesterday. What do you guys think that is? That's saying 2 to a power. If you wrote an exponent form, remember, base number power. It's saying 2 to a power equals 8. Anyone know what that power is? 2 to what power equals 8? What do you guys think? Good, Miss Sheldon. It is 3. Yep, it's 3. Everyone good with 3? Anyone? Oh, now, and I want you to know how to do some simple logs. How about the log base 6 of 36? What do you guys think? Log base 6 of 36. Miss Ford? Everyone good? 2. It's 2 because 6 squared equals 36. Okay. And my last one, remember, the answer to a log is an exponent. They're inverses. How about the log base 2 of x equals -1? Can anyone write that for me in exponent form? So can anyone write that for me in exponent form? It's in log form now. Can anyone write that for me in exponent form? What do you guys think?
Isn't it 2 raised to the 1/2?
Almost, Nick. Base number power. So it's going to be, yeah, Sean, it's going to be 2 to the -1 equals x. But then, Nick, 2 to the -1 is 1/2. So the answer is actually a half. But it's 2 raised to the, remember, this isn't a power. This is a number. Remember, it goes base number power. So it's saying 2 to the -1 equals x. So x is equal to 1/2. Okay, or you could write it like this. The log base 2 of 1/2 equals -1 because that's the exponent, right? That's how you get 2 to be a half. Here, let's try one more. What do you guys think about this one? Log base 5 of 1/25. Anyone have any thoughts on that? The log base 5 of 1/25. What would the exponent be? Sarah?
-2.
Very good, and that'd be -2. Yep, because 5 to the -2 is 1/5 squared, which is 1/25. So, you know. Everyone okay with that? Okay. So let's go back up to our log properties, which we were kind of working on yesterday. We did expanding and condensing. Okay. And basically, we talked about how when you multiply, you add your exponents. Okay. When you divide, you subtract. Now the other way you can work on these is condensing. Okay. Condensing, what I always tell kids is you just work backwards. Here's the key thing when you condense. You only write the word log once. Okay, when you condense. Sorry, this is like, lately my computer, it's just been like kind of slowing down. I think the things of having, I have a bunch of tabs open. I have 2 screens going. I have Google Meet going. I'm recording the lesson. I think it just kind of bogs the computer down. If any of you know computers, I think it's just kind of too much for it. So sorry about that. So do you see how in your examples here, do you see how the word log was only written once? Okay, so look at this one, log 3 plus log 5. Okay, so here's what you have to decide. You want to condense it down. You want to work backwards. So I'm only going to write the word log once. And by the way, remember, you don't change bases. Okay, there's no base written there. So by the way, what's the base if no base is written? Anyone remember that from Algebra 2? What's the base if no
10.
base is written? It's 10. You guys remember that 10? Okay, your calculator is set to base 10. Okay, but these are added. Multiply goes with adding. So when you condense it down, you're going to say, okay, that's log of 3 times 5, which you could say is log of 15. But do you see how you've condensed it down to one log expression? Okay. Is everyone good with that? Okay, why don't you guys try here? We'll add another one really quick. Let's say let's do one with x's and y's. Log of x plus log of y plus log of 3. Now they're all added. So So we have log x plus log y plus log 3. They're all added. So when you condense it down, anyone want to tell me what I would do with each of them? What do you guys think? Anyone have any thoughts?
Do you multiply the x and the y by 3?
Yep, good, Taylor. You kind of multiply them all together. Yeah. So in parentheses, you would write log of, however you want to organize it, x, y, 3. Or, 3xy. So you can write it however you want. Okay, you've condensed it down to one log expression. Okay. You only write the word log once. Everyone okay with that? Who just joined us? Mia. Hi, Mia. Okay. Now let's go the other direction. Subtraction. So we did examples yesterday. When you divide, you subtract. Okay. So again, write the word log once. Here are your numbers though, 4 and x. So I'm going to say that's the log of 4 divided by x. Okay. Is everyone okay with that? Here, you guys try one. Log of x. Well, actually, no, that's just easy. Division. I want to get going with the other stuff. We'll practice more. All right, and then the last one. Oop, oop. Sorry. Now, the last property we learned yesterday was you can pull the exponents down front and multiply, right? Well, when you condense, you can go backwards. So do you see how you have 2 log x? See how that 2's in front? Based on this property, it started out as this, right? You can move it back. So wouldn't that be the log of x squared plus the log of 5? So you see how you move the 2 back up top as an exponent? You're literally, when you condense, guys, you're doing the opposite of what you did yesterday. If that makes sense, okay? You're literally doing the opposite. So I'm going to say, oh, okay, that's the log of x squared plus the log of 5. Because yesterday we pulled it down front. Now they're added. So you're going to write the word log once. Adding goes to multiplied. So I'd say x squared times 5. And now you've condensed it down to 1 log. You can't leave it like this. You can't leave it like 2 log x5. Okay, that doesn't make sense. You have to move your exponents back up top. Okay, so any questions on those? Okay. And then the last one, I don't know, like, I feel like this is more for the MCC kids, but I'll show you. There's a formula called change of base. This is a very much a non-graphing calculator topic. Okay. But if you need it, here's how you do it. Okay. Remember, the common base is 10. But I may ask you guys to do a problem with it at some point coming up. Okay, your common base is 10. So like on your little scientific calculators that you get, when you type log, it's always base 10. Okay, so you didn't have a way to calculate non-base 10. So here's what you would do, and I'll show you. It's always, you write it as 2 logs. U is the number, so it's basically, it's very easy. Log of the number over log of the base. And I'll show you how you would have done this, okay? So this is like, back in my day, okay? And I'm not even that old. Although, you know what? I want to know another funny story the other day. I said something to my wife, and I was like, oh, that guy seems good. He's like a young dad like me. And my wife goes like this to me. Now, what do you think she was looking at me like that? Apparently, I'm not a young dad. I'm like, what? She's like, I'm like, oh, thank you. I get it. Okay. So back in my day, which wasn't that long ago, because I am a young dad, you had to actually use this formula. Okay. So for example, here's what I mean. Watch, if you go to your calculator, now the inspires are a bad one for you guys to be used to. Okay. It's set to base 10, or it allows you to enter the base. But if you have a scientific one, you can't do that. So like, what was the first example? Log of 12 base 3. So most of you would type this in. right? But if you didn't have that, if your calculator only did base 10, here's how you would type it in. It's very easy. You would type in log 12 on top divided by log 3. And that's how I would have done it back in my day. Okay. When I only had a calculator that was set to base 10. Okay. The other cool thing is you can even do, if you want, natural log. You can even type in ln 12 divided by ln 3. It's called change of base formula. And basically and look, you get the same exact answer. Wild, right? So you could actually do it however you want it. So this answer is 2.26186. Okay, we'll go back here. Okay. Oh, so this will be written as log 12 over log 3. And even like for this one, you could write ln 81 over ln 16, or you could write log of 81 over log of 16. It doesn't matter. Okay, which is just kind of cool. Okay. But this is for calculating this is for non-base 10 on a non-graphing calculator. It's very specific. Okay, so I'd go over to my calculator. I would type in ln 81 over ln 16, and there's your answer, 1.585. You guys good with that? So, and you can check it. It's giving you an answer. So if you see any questions like that, and like I said, guys, unfortunately, this is more for the kids probably doing the dual credit. If they ask you to compute something non-base 10 and show your work, that's how you do it. Log of the number over log of the base. You wouldn't have learned that though in Algebra 2. The kids used to learn it in Algebra 2 because the calculators wouldn't do it. But now the Inspires are so powerful. My God, they have buttons that are called NSolve. By the way, do you guys like NSolve? I love NSolve. Adriana, remember how much fun we'd have last year with NSolve in class? It'd be great. Okay, here we go. Let's look at some more. Now, we did these two yesterday. These were expanding, okay? There's lots of different ways to do this, and we'll kind of like walk through some of these here. I'm not going to get through all of them, I don't think. Okay, but we'll see which ones we get through today. Let's look at number 3. A equals log 3 and B equals log 2. Which of these following expresses the value of log 12? Okay, so let's think about it. The first thing you have to do is, how do you write 12 in terms of 3 and 2? So let's think about that for a minute. 12 in terms of 3 and 2. Anyone have any thoughts? Anyone have any thoughts? Come on, guys. Well, first off, isn't 12 4 times 3? This is what it's getting at, guys, right? Oh, gosh, guys. Or it's 2 times 2 times 3, right? Am I speaking something you don't know here? 2 squared, oh, geez, 2 squared times 3. Everyone agree? That's 12. It's said to get 12 in terms of, see log 3 and log 2. So I'm going to say, okay, I got log 12, but really, it's log of 2 squared times 3. Okay. What they want you to do with a problem like this is expand it out. Okay? They want you to expand it out. So, can anyone expand that out for me? It's multiplied. Let's think about that. What does multiply go with? Come on, from the peanut gallery. What's multiply go with? Look at your notes. Thank you, Sarah. Addition. Everyone good with addition? So I'm going to say, okay, that's log of 2 squared. Each term gets its own log, right? Plus log of 3. Is everyone okay with that? That's one of the properties we just did. What's the other property I can apply here, guys? What's the other property I could actually apply here? There's one other property I could do if I was just expanding this out. Look at your sheet. What's another property I could use here?
Put the exponent in front.
Yeah, can't you move this exponent down front? Thank you, Sean. Yep. So I'm going to have 2 log 2 plus log 3. Okay. Is everyone okay to there? The problem kind of hinted at. Now you go back to what it talked about. What does log 2 equal? Log 2 equals b. See? So it's going to be 2b. Log 3 equals a plus a. Your answer is 2b plus a. So which one is that? D. That used to be a common Regents question. It's not so much anymore, but you know. What do you guys think? Good with that? We'll practice more of those. Those are a little tricky because you have to like kind of like it's a simplifying problem. They really want you to like they're kind of like putting it in code how they want you to write the number. Okay. All right. Now, one thing they love to do is problems like 4 and 5. Okay. Log base 2 of square root of x over y to the 5th. Does anyone have any input on what's probably a better way to write square root of x? You don't want to leave radicals. You want things with exponents because we can do the exponent trick. So how do you write radical x with an exponent? What do you guys think?
X to the 1/2.
X to the 1/2. Come on, guys. More of you could be like chiming in here. Thank you. X to the 1/2 over y to the 5th. Okay. So take a minute. Tell me which one you think it is. After you expand it, it's division. And maybe bring your exponents down. So take a look at your choices. I can zoom in a little bit. If you had to guess on a multiple choice question, anyone want to tell me which choice it would pick?
C.
Who said that?
Deborah.
Deborah, thank you. You guys good with C? Does C look right? Yeah? Taylor Sheldon, you agree? Yeah, I think so. Let's show it. It's division. Division goes with subtraction. So I'm going to write log base 2. You can do this in one step or multiple steps. Don't do the exponent part till the end though. So remember, division goes with subtraction. So at least now A doesn't look right. And you know, bring down, by the way, the common mistake here is kids write that as squared instead of 1/2. Bring down your exponents. So the answer is choice C. Yep, very good. Okay. Good so far? Okay. How about the next one? Log base 3 of radical 5 over 27. So you got log base 3. I'm going to write this as 5 to the 1/2, right? Minus log base 3, 27. Now, this one I thought they wrote the answer weird. Because remember, radical 5 is the same as 5 to the 1/2. Is everyone okay with that? Okay. By the way, what's the log base 3 of 27? Anyone know what that is? That's actually a number you can compute. Thank you, Sean. It's 3, right? 3 to the 3rd equals 27. So this just becomes 3. Okay. And then I can bring the 1/2 down front. So you have 1/2 log base 3 of 5. Now, this is how I want you to write the answer. Okay. That is actually equivalent to choice A. I don't know why you would ever, they wrote it as one fraction. They kind of like made a common denominator. See what they did there? They made the common denominator 2 and made it, I want you to write it like this. Okay. So. What do we think so far, guys, about expanding and condensing? Doable? This used to be an Algebra 2 topic that kids usually weren't like hating me during, which is always a positive in my world. Okay. All right. We'll come back to do number 6. Why don't you try let's jump ahead and look at number 8. Now, when you condense, here's my advice. I'll give you a chance. Move the exponents back up top first. So it's literally backwards. Before I say move them down at the end, when you're condensing, you're working backwards. So move them back up top. Move exponents up top first. Okay? You're literally working backwards. Okay. So the first thing I would do if you're showing your work, do you see how these numbers are in front? They came from up top, right? So you would write log base 2 of 8 to the 1/3 minus log base 2 of 2 to the 3rd. Is everyone okay with that step to start? I literally just moved the exponents back up top. Okay. It's subtraction. What does subtraction go with, guys? What does subtraction go with when you condense or expand? Subtraction goes with what?
Division.
Division. Division. Yeah, good. Division. So I'd write it as log base 2 of 8 to the 1/3 over 2 to the 3rd. Remember, and you only write the word log once. Here's a common mistake kids always do. They'll write this. So hopefully you're all paying attention. They'll write this. Log base 2 of 8 to the 1/3 over log base 2 of 2 to the 3rd. You never saw, this isn't change of base, okay? You don't write it with the word log twice. You only write the word log once. So you could leave it like that, or you can make it log base 2. 8 to the 1/3 is 2 over 8. And you can simplify it even, But I'd be happy with any of these answers. Okay. Hold on. No. Okay. Yeah. Right. Everyone, now, put a star by something like number 9. As these are about as tough as they get, okay? Oh, hold on. Okay. Where'd you all go? There you are. The first thing I would do is I would say, okay, you can write this as log base 2. Do you see how this whole thing's under the square root? So you're going to make that, okay, 32x to the 7th all to the 1/2 power. Is everyone okay with that? The whole thing to the 1/2 power. Okay. We good with that, guys? Now you're expanding. What should you probably do first, guys, if I'm expanding? Anyone have any thoughts? Can you maybe unmute yourself? What would you probably do first if you're expanding? You can't
bring the 1/2 front.
Thanks, Aiden. Yeah, totally. Yep, bring the 1/2 down front. Everyone good with that? Now here's the thing. The 1/2 is just going to kind of hang out up front. So sometimes I say write 1/2 and then do your expanding and just put like brackets or big parentheses there, because the 1/2 now is just going to kind of hang out front for the whole problem. Okay, that's all that's really going to happen. The 1/2 is just going to kind of hang out front. So now 32 and x to the 7th are your terms. They're multiplied. Multiply goes with addition, correct? So I'd say, okay, that's log base 2 of 32 plus log base 2 of x to the 7th. You see how I never change the base with a log, and each term gets its own logarithm. Do you see any last steps you could simplify? Well, oh, sorry. Well, does anyone know what the log base 2 of 32 is? Anyone know what that is? That's kind of a sort of common power. 2 to what power equals 32, guys? Does anyone know? Oh, come on. It's 2 to the 5th. 2 to the 5th equals 32. That's okay. And then what can you do here? What's my last? I have one more thing I can do here with log base 2 of x to the 7th. What do you guys think?
Take the 7 and put it in front of log.
Thank you. Yep. But only in front of this one, because it only applies to the x. And there you go. You can multiply that through if you want. I'd rather you just leave it like that. But, you might see someone, oh, now multiply the 1/2 through. So you get 5 over 2 plus 7 over 2 log base 2 of x. Everyone good with that? Okay. Now, I want to show you a couple other examples before we go. A couple things here. The rules don't change if you have, I'm going to add a few examples. The rules don't change if you have a natural log. Sorry, let me rewrite that. And we'll, you know, so this says the natural log of 2e to the third over x squared. Okay. Same rules. Each term gets its own ln. So now this is a combo pack. It's like when you go to the store and you're looking at something, you get a variety pack. You have multiplying and dividing. So the 2 and the e are going to be added. Everyone agree? So I would say, okay, so I have ln 2 plus natural log of e cubed minus the natural log of x squared. Each term got its own natural log. Does that make sense? Adriana, you good? But does everyone understand why I added and subtracted? Okay. Now, are there any exponents I can pull down front? Yep, I have a 3 and a 2. Let's just do those. ln 2 plus 3 natural log of e minus 2 natural log of x. So don't worry, guys. The problem doesn't change when you get to ln's. It's exactly the same stuff, okay? You don't do anything different when you get to natural logs, if that makes sense. Now, by the way, does anyone know what ln's and e's do? We're going to review this a little later. Anyone know what the natural log of e is? They just cancel out. It's like a 1. Okay, so we'll talk more about that. So yeah, and ln 2 plus 3 minus 2 ln x. It's pretty good. Okay. Any questions? Not very exciting, is it? It's pretty easy, though. I don't know. What do you guys think? Hard or easy? Emma Thorpe? I know. It's okay. We're going to actually skip this one. And let's, I want to add a different, sorry. We'll add a different example here. We'll do a tricky one. Okay. Let's write this down. I'll do ln's again, just to show you that it doesn't matter whether you're doing log or natural logs. Hold on, let me erase. Before you all get mad at me, I'll show you how this isn't that bad. Oh, let's all make these x's, I guess, instead of a's. You might want to write that one down. Okay, that looks like a gigantic mess, doesn't it? And all the directions say is expand. Okay. All right. Anyone have any thoughts on what you could do first? What should probably be rewritten first, if that makes sense? What should you probably rewrite first or put in there? And I'm hoping you guys have noticed a pattern here. What should probably you just rewrite first if you ever see it in one of these problems? Anyone have any thoughts?
X squared minus 1 under the radical.
Good, Taylor. And how would you write it, hon?
X squared minus 1 to the 1/2.
Thank you. Yep. You want to get rid of radicals. Okay, so we got this now. Okay. Very good. And thank you, Sean. I saw yours too. Everyone good with there? Now I can start expanding. Okay, each term gets its own ln. Same as log. Okay. So top is multiplied, bottom is divided. So I got adding and subtracting. So let's do it. ln of x cubed plus natural log of x squared minus 1 to the 1/2 minus natural log of x plus 2 to the 4th. Is everyone, this is really important. Is everyone okay to hear? If you have a question, guys, please speak up now, because this is the key part. The last step is really easy. You see how each term got its own ln? Each term, and then you go from there. What do you guys think the last step is? Anyone have any thoughts on the last step? It's not really tough. Just, you got a bunch of exponents there. What do you think you do with the exponents, guys? You're expanding. No?
Bring the exponents down.
Thank you. Yep, all of them come down front. So I would write this final answer to get full credit. I would write it as 3 ln x plus 1/2 natural log of x squared minus 1 minus 4 ln of x plus 2. Now this always comes up. Some of you really love math and are advanced. Kids will always say, can I just pull the exponents down in one step? Yes. But if you're struggling, you can, I will never penalize you for showing more work, right? But if you want, you can always pull the exponent down front in one step. I get it. Okay. So now that you saw that problem, it looks like a gigantic mess, right? But it's not that bad, is it? And some kids will always say, wait, do you have to do anything with the x squared minus 1 and the x plus 2? I mean, you could factor it, but it doesn't help you. So just leave it. Okay. All right. Last one, and then we're done. Let me pull it up here. Let's change it to log base 2, 3 log base 2 of a minus 2 log base 2 of a squared plus log base 2 of a. No, log base 2 of b. We'll just change it to, we'll change the number to b. Okay. Now, why do you think, guys, with a problem like this, when you're condensing, so obviously when I finish up, I'm going to just have log base 2s. First step when you condense is pull these back up front. Do you see how this was? Oh, I did it. I wrote it as I did it. I didn't want to write it as log base 2 of a squared, just 2 log base 2 of a. Get it? Okay, and then log base 2 of b. Actually, I could leave that 2 there. It doesn't matter. We'll talk about how to do it. I probably wouldn't do that to you, but do you notice? Do you see how real quick though, guys? The last step before. Look at the last step. The last step when I expanded, because the directions for this one will say condense. The last step was pulling the exponents down. The first step here is putting them back up top. Does everyone see that? You're literally working backwards. Okay, so this would be log base 2 of a cubed minus log base 2 of a. Now this is actually 2 squared, so we'll say a to the 4th. You had to multiply your exponents. Plus log base 2 of b. Okay. When you condense, you only write the word log once. Why do you think they put the parentheses there? What is the parentheses to help you do? Anyone have any thoughts? Why do you think they threw parentheses in on this one? Come on, we're just about done, guys. Why do you think they put parentheses in there? No?
To add those 2 first and then subtract that from the log 2 a cubed.
Well, yes, but here, yes. Yes, so Aiden, though, subtraction goes with division, right? So a cubed is going to go on the top. They want you to make sure you understand in the bottom, those are multiplied. They get added. So you're going to have a to the 4th times b. Does that make sense? These kind of stick together. Okay, so did I lose you guys on that, or is everyone okay with that? They stick together in the denominator because remember, you have division goes with subtraction and adding goes with multiplying. So you got to kind of stick things together. Okay. Everyone okay with this so far? What do we think? Not bad, right? And we'll keep practicing it. All right. Because I want when we come in, I will do these problems as we're gonna do this to start next time. Okay. Hold on. I'll say start number 7. Okay, here's your question of the day. This is a simple one. I'm gonna stop recording. By the way, keep working on your math excels. I know it's